All right, good evening, everyone. A few people still coming in, so we will get the program started in a minute or two here. Hope everybody is doing good on a whatever day today is, Thursday evening.
Doing good. Jay Vintner sideways. That's better.
Hey, Dave, how's it going?
Good, Lance. How about you?
I'm doing okay. Let's see. Okay, we're at 15 now. I think we may have a handful of others that should join us here shortly. So I guess while we're waiting on a couple more people to join, I'll just get started real quick with 2 seconds of introduction for everybody. Is number one, welcome to I guess this is officially our first SoCal NOMA and Southern California Edison joint event. We're very happy to have a new partnership with SCE this year, and excited about the ability to bring new opportunities and offerings to all of our members to learn more about sustainability and energy efficiency. And definitely a big thank you to Dave, to Ruby, and everybody on the SCE side for helping put everything together. So we're grateful for having you guys as a chapter partner here. Tonight's event is going to be focused specifically on building electrification, which is a really timely, critical topic as far as getting to decarbonizing buildings and reducing fossil fuel emissions in buildings. So we're great to be able to share that with all of you. Hopefully, it'll be some really great information to take back to the projects that you're working on. I will do a couple of shameless plugs here. Our next SoCal NOMA General Body meeting is going to be on Thursday, May 27th at 6 p.m. We are going to be doing a session specifically on real estate development and kind of the architect's role in that and developing an underserved community. So please be on the lookout for more information on that. Hopefully you guys can all join us for that as well. And then we have a couple of other joint sessions with SoCal Edison coming up in the future over the next couple coming months. Can't talk. So we're really excited about that. Dave, I don't know if you wanted to add anything onto that or any more on your end.
Sure. Yeah. No. It's been a great start to the partnership, and really appreciate the opportunity to be able to have engage in the dialogue with your membership, and to be able to talk about the goals in our pathway 2045, which is the clean energy and electrification pathway, looking to electrify end uses to take advantage of the ever increasing clean power that's available through the electric grid, and eliminate fossil fuel end uses in transportation and buildings. And as part of that, we're trying to get to 70% reduction in space and water heating end uses in buildings by the 2045 timeline. And so Nick's presentation tonight is going to talk a lot about some of those technologies, as well as other elements of clean energy homes that we want to make sure that folks are aware of, and kind of understand how to integrate into their own designs and practice. And we'll be looking at a lot of other stuff as we progress as well. So really appreciate the opportunity to engage with you guys, and look forward to this ongoing partnership.
Sorry, I'm trying to do 3 things at once. If I can put something in the chat. We are recording this meeting, so there will be a video link for this after the fact. I just put into the chat, there is a attendance list. If you can fill that out, it's a Google document form so that we can get CEU credits for everybody here. So if you guys can complete that form, if you need CEU credits, that would be great. And I will turn it over to Anthony to get us kicked off.
Hi, everybody. Some of you may or may not know me. I am Anthony Winston III, and just as Lance mentioned, this partnership with SoCal, with NOMA and SoCal Edison is pretty timely. The goal of the partnership is to educate the membership on clean energy and code compliance, specifically with Title 24, also on renewable energy, HVAC requirements due to Title 24, lighting and lighting controls requirements as it relates to Title 24. Since I'm in MVP engineering, I was brought on to assist with the selection of the requirements to build these courses. Then Edison then sponsors and puts these webinars together. Just from my personal experience, I can't tell you how many times we've completed our engineering designs and lighting has to change to meet Title 24 compliance, or an HVAC system that the client wanted to use can't be used because of Title 24. Not to mention, cities in California are slowly starting to ban natural gas, which is really going to affect us and force us to use, things like all electric heating. So these courses, they're beneficial not only for your continuing education credit, but also make the design process much easier between, architects and engineers such as myself, which, saves you time and money.
Great, thank you. So I think without further ado, I think we got almost everybody here, so everybody else is late. Without further ado, I'm going to turn it over to our speaker for this evening, Nick Brown.
Awesome. Thanks, guys.
Glad you could join us, and we're all looking forward to your presentation tonight.
Yeah, great introduction by both Lance and Anthony. And Lance is going to design an all-electric building while I speak tonight. He said he's got a few things he's got to juggle. But I did want to call your attention to some other programs that you guys might be interested in. If by the end of tonight you're not already sick of me, the full-length all-electric designs class is being offered June 10th through SCE's Energy Education Center. You can sign up for that online. That's 4 hours. So that gives you an idea of how much material I've tried to compress in here. But as I told Lance while we were getting going, I'd much rather this be interactive and you guys shout out your questions. I've got chat up on my screen here. I should see it if you want me to stop, because I'd much rather focus on what's most important to you than cram more material in there. Also might be interesting to you, July 7th and 8th is a 6-hour course, the Energy Code for Residential Architects that I teach. That's through energycodeace.com. And then June 7th and 8th is the non-res version of that. Gina Rada teaches that. She's an absolute guru on this stuff. So in case you want to dig into it a little bit deeper. First, Dave Intner of Edison, thank you, introduced us. They sponsored the development of this class. And I always like to start by saying, let's address the question that comes out of the back row, second from the left most of the time. Why is Edison wanting us to use more electricity? And the truth is, utilities are separate from the production of our energy, right? It's a decentralized situation where what they're responsible for is managing customer accounts in the distribution system. And so what they're really more interested in is this second bullet. They're interested in supporting the state's transition to a renewable electricity grid. And so this Pathway 2045 document is nicely done if you want to read more about it. So I think you really can believe that they have our best interests in mind when they put together a class like this. Quickly, where I'm coming from, I'm a Title 24 consultant, a certified energy analyst, a KBEC board member as well. So that's what I do for a living. And I live in this net zero house in Long Beach. And I wish I knew then, about 5 years ago now, what I knew now about building electrification, because I put in a gas furnace, I put in a gas tankless water heater. I was smart enough to put in an induction cooktop, and eventually smart enough to put in a heat pump dryer. But I still have two major end uses on gas. And it was because I didn't understand the greenhouse gas picture, the comparison. So I'm going to show that to you today. But the house is performing great. I haven't paid an electric bill since we moved in, which has been great for my growing energy consulting practice. And as you can see on the Edison bill shown here, our house overproduces a little bit. So today I want to cover, again, this is a compressed format, the reasons why all electric, the systems it takes to do it. Let's demystify those. Title 24 compliance, you might be surprised to find, is easier all electric than mixed fuel. And that's very different than just a few years ago. I'll show you that. Cost, right? A conversion like this can't ignore cost. In fact, we've really got to lead with cost. Lance was saying he's got a program with developers, how to work with developers. That's going to be their first question. So we'll look at that. And then we'll take a step back and look at how this fits into the statewide transition to renewable energy. And if there's time permitting at the end, let's do some case studies. If, on the other hand, you're shouting out and bringing in your own material, so much the better. You'll have those to refer to at your own leisure. So the reasons to do it. First of all, it helps our state achieve its climate goals. Easier Title 24 compliance, lower cost, health of occupants and indoor air quality. This is a key metric that a lot of builders aren't focused on at all. And the all-electric home has a really compelling story to tell because there's no combustion of gas indoors for cooking, no combustion of gas indoors for clothes drying. So it makes a great difference in respiratory health. Those families with asthma, I think it affects 1 in 7 families in California today. So they're going to find this very compelling. And when we're required to build with solar panels on all new residential multifamily buildings, single family homes, it just makes sense to run more of your house off electricity that's being produced on site on the roof rather than gas. And those of you who work on multifamily have seen buildings look like this picture in the middle. There's a whole lot of money in gas infrastructure and gas meters and delays and an extra utility as well. So a lot of reasons to electrify homes. Even putting aside the regulatory, the REACH code, the state's climate goals, I hope you'll find by the end it's a compelling value proposition in and of itself. And we really should be looking at building more and more of our homes and multifamily buildings all electric starting now. I've gotten a lot less timid about putting an all electric design in front of an architect client, usually next to a mixed fuel design for them to consider. And just a few years ago, I would have been a little nervous to do that. I would have been afraid they'd call me a tree hugger and write me off and not give me their next job. But this is so compelling as a value proposition, so important as a state. I'm doing it a whole lot more, and I hope you'll consider doing so as well. First, our climate commitments. Our state legislature has committed us to a number of aggressive climate goals. 40% greenhouse gas emission reduction by 2030. The second one, the electric sector, is committed to be 60% renewables by 2030 and fully renewables by 2045. That means if we build an electric building today, it takes advantage of that greening of the electricity grid. Whereas if we build it with gas today, that's locked in, that section of the building. Carbon neutrality. 40% greenhouse gas reduction in buildings by 2030. So right where you and I are working every day. Incentives coming through the Tech and Build program, yet to be announced specifically what those look like, but I think you'll find incentive money on heat pumps and heat pump water heaters are on their way to help support this transition. And of course, we can't forget our part in the worldwide effort in the Paris Accord to ensure we don't go too far on CO2 emissions. So that's the state level goals, and many local areas are pushing further with what we call REACH codes. These are energy codes that go beyond the state minimum and only apply in those local jurisdictions. 15 or more of them are all electric today, including down in our area, Ojai. Others are electric favored, kind of a nudge to the all electric option. They make it a little bit more difficult to build mixed fuel than all electric. And Santa Monica is a great example of that one. They've been long been a leader in this area, and others have other specifics. If you're working in an area you're not familiar with and you're not sure if they have a REACH code, this website will tell you immediately. Continuously updated and a great source of information. Here's the one slide I wish I had when I remodeled my house. This is from a really readable E3 study, reference there. It shows the ton of greenhouse gas emissions for a mixed fuel house today and an all-electric house today. These are single-family new construction that I'm showing here. 41% lower for the all-electric design. And as that electric grid greens, look how much that bar drops on the all-electric house. 59% better by 2030, 83% better. And that's a tiny little bar compared to the mixed fuel bar that is the status quo. That's why we should consider all-electric building, if nothing else. So that was the quick and dirty regulatory picture. Let's talk about the systems it takes to do it. I don't see any questions in the chat, but did anyone want to shout out yet?
I had a quick question. When it comes to residential or doing renovations for multifamily or something like that, you're kind of beholden to what the utility has. Can you explain where that cost goes? So if I have, let's say, a 200 amp panel on an existing home and I want to add all electric, right, including the EV charger, that means that my power demand has gone up and I may need to upgrade my panel. As the homeowner or the owner of this multifamily unit, is that cost on the utility or is it on you as the owner?
I saw the PE after your name, and I would expect nothing else than a great question like that from you. Yeah, the panel is the homeowner or the building owner's responsibility. Getting power to the curb is the utility's responsibility. So you're absolutely right. There's going to be cases where that panel, maybe 100 amps, was sized for 1920. And you're going to have to upgrade that as part of an all-electric remodel. But you'd be surprised. When we talk to HVAC contractors, they say less than 20% of the time are they finding they have to upgrade the panel. Because if you already have an air conditioner on site, you can convert that power to a heat pump, generally with no additional amperage. The water heater, yeah, if you're switching that from gas to electric, that's 30 amps you're going to need to find. And good point, Anthony. We're going to need room in our panels for EV charging and solar panels if we don't already have them. And so when we go through a major remodel like that, it's worth building the all-electric into it at the same time. Other questions?
Can I piggyback on that? This is Drake. So since we're talking about the power, and I'm assuming we now have to store that, so the battery is now a component that we did not have before. How is that impacting things?
Not necessarily a requirement. A battery is an optional upgrade. Think of the grid as your virtual battery. And your electric bill is going to be constantly tracking, when you have a solar system, what you're putting back on the grid. It's like putting dollar bills in a cash jar in the kitchen. You're building up credit that you can draw against at night when the sun goes down. That's called net metering, right? And so you don't have to have a battery to take advantage of the economic payback on a solar system. The battery will help you in case of a blackout, in case you want resiliency. It'll help you arbitrage, sort of, right? Store the extra solar produced in the middle of the day and use it when electricity costs the most in peak periods. It'll also make your house a friendlier to the grid. Edison would love to have more homes with batteries installed, but it's not a mandatory requirement. That answer your question, Greg?
Yes, it did. But you are making an assumption, though, that Edison will be there for you.
That's right. But aren't we making that assumption in a mixed fuel house today, too? How much better off are we with gas service? Can't run your fridge. You know, maybe you can cook meals on an old cooktop, but all the new ones have electric starters. So does your water heater. So I don't buy that argument.
Yeah, it's just that some of the more recent solar panel owners were very disappointed when the sun was not around when they wanted it to be around, and they were not able to generate the power as needed, particularly at night. So that's why I mentioned battery.
And some of them were also upset because they didn't realize in case of a blackout that their solar panels weren't going to continue producing power. And that's how it works. Yeah. Because we can't be putting stray electrons on the power lines when the crews are out there trying to restore service. So the battery allows you to keep the lights on in those cases. Yeah.
Unless you're totally off grid, but that rapid shutdown is if you're on the utility, that has to be in place.
And totally off grid is a possibility these days. You're going to need a lot of battery, but I just did a project like that where that's what the homeowner wanted. 4 Tesla Powerwalls, they were off grid, but that's not for everybody. Well, let's go through the systems, but thank you so much for participation. And I'll pause at the end of each system here for further participation. In a typical Southern California home, plug load, appliances, lighting, biggest slice, but cooling, then heating, then water heating are the others. So all electric targets cooling, heating, and water heating, right? And the systems are really not that complex. This is not science fair stuff. We're going from a gas furnace to a heat pump on heating and cooling. We're going from a gas water heater to an electric heat pump water heater. We probably all aware there's been electric clothes dryers a long time, and we're going from a gas cooktop to hopefully an induction cooktop, because that higher tech, more efficient, more comfortable, more safe approach to the electric spirals that we may have grown up with that just weren't as favorable a cooking experience are the way to go, in my opinion. Slightly more money up front, but that's what we're talking about, transitioning those 4 end uses off gas. So let's start with the HVAC. This is the biggest slice of the pie that's typically gas. And we've become really good at building with design number 1, the gas electric hybrid system. And that system's more complicated than the other three, which are all electric heat pumps, aren't they? I mean, you can see just looking at it, because we've got a gas line going into that furnace up in the attic with the air handler. We've got refrigerant lines to the outdoor air conditioner to that same air handler. We've got a flue vent pipe up through the roof to let those combustion gases out. And we've got duct snaking around the attic. That's how we're building homes these days. Well, let me show you the three heat pump alternatives to that. Starting with number two, the closest cousin of number one, a conventional heat pump. It's got a similar duct distribution network up there in the attic, but gone is the gas line and the furnace. Instead, we've got a heat pump, which you can think of in its simplest terms as a reversible air conditioner. It can pump cold air or it can pump hot air. So we're doing with one system what the two systems, the gas furnace and the air conditioner, were doing before. That's where the simplicity comes in this diagram. Still got refrigerant lines to the outdoor unit. Number three, I would argue, is the simplest to install, to maintain. You've got indoor units installed around the house. Here we're showing a high wall unit, but as I'll show you in a few slides, there's other ways of getting that indoor air distributed. And they're just connected with refrigerant lines to the outdoor unit. And that's going to be all electric, providing heating and cooling depending on the outdoor conditions. And the ducted mini split in number four, kind of a hybrid. It's got all the same guts that the ductless mini split has, indoor unit, but it's hidden up in a drop ceiling or an attic somewhere. And it's got generally a smaller, more compact duct distribution system, because these don't have the same huge fans, high static pressure that a traditional air handler does. But much simpler, no gas, and they can have the traditional aesthetics that a lot of home buyers prefer. So the ducted mini split, I think, has a nice sweet spot in slightly larger homes, production homes especially, quite often going to be lower first cost to install than a ductless mini split if you've got multiple rooms that you're talking about. But that ductless mini split's going to be ideal for an ADU or a small addition, or where you've got 2 or 3 heads. That's probably going to be the lowest cost option. And how they work is remarkably simple, although this term heat pump has taken on a life of its own as sort of science fair stuff. In cooling season, shown on the left, what we're doing is we've got a lot of heat building up in the house, coming in through the building envelope created by the people. We're going to pump that out through the refrigerant lines and expel it to the outdoor space. And that refrigerant now has lost all its heat, gets pumped back into the house nice and cool. We blow the air over it and cool the house. That's just like an air conditioner, right? What we're all used to. On the right is where it gets different. Now we're going to switch directions on the refrigerant flow. And we're actually able to harvest the heat in the outdoor air, even in wintertime. Doesn't have to be 90 degrees for us to harvest heat. These compressors are able to pull heat out of extremely cold air down all the way to 5 degrees Fahrenheit with the variable capacity models. And so they're going to condense that heat up the refrigerant, pump it into our house, and we're going to blow the air over that and supply heat to our space. So all that's happening is we're reversing direction of the flow. And here's what a cutaway of these systems look like. Shown here is the outdoor unit sitting outside, connected with refrigerant lines to the indoor unit. And contained in that indoor unit is a return, a supply, and a coil, as well as the fan. There's a filter in there as well. So the advantages of these are there's no energy loss from ductwork, And I'm working on a project right now where two-story house is going to have 3 ducted mini splits and 1 ductless mini split, all connected to 1 outdoor unit. So they're modular, they're flexible. These really are, they are technologically advanced. And each indoor unit can have a different temperature set point too. So they're ideal for home offices, blended families where everyone wants a different set point. You want to shut off a zone during the day. These are great for that. And their efficiency comes from the fact that they're not just on or off like a jet engine. They're going to modulate up and down the delivery and heating and cooling according to the load in the space. So they operate a lot of the time at part load conditions, which is where they really hum and are most efficient. Now, they don't have to look like that high wall unit. Shown here is a ceiling cassette. It's a one-way ceiling cassette, I think very attractive and sleek. All the guts are hidden up in that drop ceiling.
I am so happy to see this. I was worried for a minute.
You didn't like those aesthetics, huh?
No.
Yeah, I hear that a lot. And the ceiling cassette in the middle is a 4-way, so it's sending heating and cooling in all 4 directions. I don't know of any homeowners who are going to object to that look. But if they are, I got something for you too. And that's these guys. Ducted mini splits, same guts, recessed up in the drop ceiling, but now we're going to have just short little duct runs up the side of that unit. And you can see you can fit it in a 12-inch, 18-inch deep space. So great in a hallway or a walk-in closet bathroom where you've got slightly lower ceiling height. So they allow you to have this type of aesthetics. You know, nice linear diffusers shown here. You could have standard diffusers, registers as well. So ducted mini splits give you most of the efficiency of the ductless units. You might get a little bit of duct losses, right? But you're still going to modulate up and down, unlock those efficiency gains there with traditional aesthetics. There's even, for those of you in multifamily, package unit heat pumps. You've probably seen some in hotels and motels like the one on the right. The one on the left is is relatively new to the market. It's called Epica, and it's a through-the-wall unit heat pump. Doesn't require a condensate line, and I think pretty good looking. Questions on heat pumps before we go to water heating?
Hi, this is Dara. I have a question about the refrigerants that are typically used in heat pumps. Do they tend to be low greenhouse gas emitting refrigerants, or is there a variety? And if there's a variety, are there specific products?
Yeah, great question. And we're paying more attention to the refrigerants we're using because they have such great greenhouse gas global warming potential. These use typically R410A, and Anthony, jump in if I get anything wrong, which is a current refrigerant. I wouldn't say it's better than your standard air conditioner. It's roughly the same. But you're accomplishing heating and cooling with that same refrigerant. There are some heat pumps coming out with CO2 refrigerant, much preferable from a green global warming standpoint. But I don't know of any of these units that use CO2. There's a water heater heat pump that uses CO2 made by Sandon. So maybe we'll start to see those come on the market here soon.
I have a question on the ductless mini split systems.
Yeah.
Are those a good system to use for multifamily, or is it more efficient to have for like a single family residential project?
To me, they're ideal for multifamily. Yeah, absolutely. You need to find a place for those outdoor units, either on the roof or on the balconies I've seen as well. So a real high-rise multifamily, you start to run out of space on the roof.
Are they cost effective?
They are. Absolutely. Because let's say you've got a 1-bedroom, 1 unit in the living room to cover the kitchen too, and 1 in the bedroom, you're done. That's going to be more cost effective than any other option. When you get to 2-bedroom, 3-bedroom units, you might start to hit a break-even point where a ducted system might be a little bit less money, because each indoor unit is an incremental cost.
Thank you.
I love the back and forth. Thank you, guys. I'm used to teaching to blank stares, so this is refreshing. All right. Heat pump water heaters then? Let's move on to the next biggest slice of the pie in Southern California homes, which is water heaters. So to switch from we've come to love our gas tankless water heaters, haven't we? They are more efficient than the gas tank ones were. They take no footprint. They get us Title 24 credit, some of them. So finding a space for our new heat pump water heater tank is going to be a bit of an adjustment. But I think there's enough to like here that you're going to find a way to do it. They have the same efficiency capability as the HVAC heat pumps we just showed you, what we call COPs of 300%, which means 3 times more efficient than an electric tank or a gas tankless. They also have the ability to, using their programmable controller, only function when the electricity is lower cost. So that's working on a time of use basis. And in fact, they can raise their set point during the day when you've got excess solar, store a little extra energy in the water tank, and then coast through the peak period. So the utilities and the state really see these as a demand response measure, as a way to make a house work more in harmony with the grid and be less of a burden with the grid. So SMUD already has a program where they'll pay you every month a couple of bucks to have yours wired into the network, and a $150 one-time rebate. So stay tuned for similar programs, I think, elsewhere. They do require a little bit of extra care with placement because, at about 40 decibels, they're like a dishwasher. You wouldn't want your dishwasher in your closet of your master bedroom either. So corner of a garage is a great place. An indoor closet next to the laundry room is a great place. But they can't go everywhere. They can also go outside. In a Southern California climate, you're not going to have much of an energy penalty to do that as well. If you put it in an open garage, you're done. If you put it in a closet, though, you're going to have to provide for airflow, because remember how I told you that outdoor unit in wintertime is taking the ambient air and concentrating that heat and putting it into the space? Well, this is doing the same thing. So it needs a certain amount of airflow around it from which to pull that heat. And it's going to expel cold air. So you need a closet with a louvered door. The manufacturers all have documents on how to do this. Or you can install ducts, as shown in the bottom 2 pictures, to either bring in fresh air from outside to the unit or expel the cold air to the outside, or both. So that's a good solution to when you don't want it interacting overly with the environment you're in. I won't go into the details here, but suffice it to say, the top table shows a heat pump water heater from a manufacturer. The bottom shows the gas tank water heater, and you can see that the recovery rate of a gas water heater is faster than the recovery rate of an electric heat pump water heater. That shouldn't be a problem, except on that one day a year when the whole soccer team comes over to shower at your house, or you have the whole family at Thanksgiving. You might need to set that in hybrid mode to have the extra boost from the electric resistance coil just on that one day a year. But a 50-gallon is going to be good for a family of two, a 65-gallon for a family of 3 or 4, and an 80-gallon for a larger family than that. I've had nothing but high fives in projects we've installed these so far. Questions on water heating?
Yeah, I had a question. How do those compare to, it was a two-part question. How do those compare to the tankless gas water heaters? And then two, have you seen anything on the market that's an electric tankless water heater that's affordable and efficient?
Affordable, yes. Efficient, no. Let's take the second question first. These have a 3.4 COP. That means 340% efficient. How do they do that? Well, because they're not burning a fossil fuel to heat the water. They're taking what's already around it in the ambient heat in the air. An electric tankless water heater, they make them. They're popular in Florida and Arizona, but they never beat 100% efficient, right? That they just can't. Same with an electric tank. So if you're gonna go electric, heat pump water heater has to be the way you do it. Electric resistance is a no-no today when we have such a superior technology in heat pumps. They are out there, but you'll have real trouble complying with Title 24 with electric resistance water heating. Dave?
Nick? Yeah, Nick, I was, oh, sorry. Was there someone else?
Yeah, I had a quick question. So how do you get around the gas cooking 51%? Because I think it's more than 51%. And,
Do you?
and people who cook, gas is the way to go.
Yeah. Dave, did you want to chime in before we go to cooking?
Yeah, well, it was just a point on water heaters before we moved on. Was just I wonder if you could touch on the 15 amp models that plug into a standard 120 outlet that are coming to the marketplace later this year. I know I was on a webinar today. GE, A.O. Smith, and Rheem all have products that are about to hit the market for the retrofit. Maybe you could touch base on those and how that can help with panel upgrades.
Yeah, thank you. In the top table here, you can see electric breaker size, 30 amps, and that's 220 volt, 30 amp, right? Like an electric dryer circuit or an RV circuit. That's a considerable circuit, and that's going to be a problem in retrofit applications. Not a problem in new construction at all. But in retrofits, yeah, if you're switching from gas to a heat pump water heater, you may not have that on your breaker. So that's where these new models that are 15 amp, 110 volt, 120 volt, greatly facilitate the transition to all electric for retrofit applications. And they do it, as I understand it. They're also going to have limitations on recovery rate when the whole soccer team showers at your house. But they're going to get around that by having a higher temperature set point in the tank and then mixing valves so that what you have stored in the tank goes further.
Nick, I have another question. Sorry, related to multifamily. Is there a benefit to using a heat pump water heating system in a multifamily setting versus going with like a solar thermal water heating system?
Yeah, boy, you guys are rolling out all the good questions. prescriptive standard, what we've gotten used to in multifamily building is a gas boiler with a solar thermal preheating system, right? So I would put forward to you, if you're going to go all electric with that multifamily building now, a heat pump water heater in each unit is one option. If you're designing the building from scratch, put those heat pump water heater closets off the corridors to house 2 or 3 or 4 in one closet. That way you can maintain them, less of a noise problem. And then the other option is what they call the skid model. 8 or 10 of these tank heat pump water heaters providing hot water to 20 or 30 units, all ganged together. So the answer is yes, there's heat pump water heater solutions to electrify multifamily buildings. People like Redwood Energy and Gable Energy are at the forefront of this transition. They've been doing it for 10 years. So I encourage you to look at some of their publications on multifamily central heat pump water heating.
Awesome. Thank you.
I have a question around that as well. So bear with me. I'm assuming what you just indicated. How would that impact the facade? And what I mean by that is that what I have noticed in a lot of cases is that when you start having individual type units, it has a big impact on the design of the facade and penetrating the skin.
You shouldn't have to penetrate the
envelope. I'm
envelope.
assuming what you just indicated will have the same.
Yeah, let's say we put one of these in every unit.
Right.
You shouldn't have to penetrate the envelope at all.
Okay.
You need a condensate drain, and you need a louvered door or an access to a corridor so air flows in and out.
Okay.
So I wouldn't see an impact on facade.
Okay.
I mean, it's taking space though, right? You're going to need to find these 2-foot square footprints.
What about vents in terms of intake or exhaust?
That's optional. In this diagram here, the ducting's optional.
Okay.
Yeah. Good questions, you guys. I challenged you to blow me away with questions, and you have been. Please keep it up. So this was, and sounded like you guys were ready to go into cooking, so let's do it. This was a Quebec poll taken, and all our members are saying gas cooking as the biggest obstacle. So let's dive into that. Although I will say I talked to an engineer today who said half of his clients are asking for induction cooking now. Now he works in Northern California, but I think it's coming. Now this indoor air quality piece is the absolute key, I think, to unlocking that hesitancy on giving up their gas cooking. These recent studies show 4 out of 9 natural gas cooktops exceed NOx concentrations. The UCLA study found after only 1 hour of cooking, 90% of the homes exceed those limits. And most people don't run their vent hood, right? We all know that. They're loud, they're annoying. And so that just concentrates those combustion byproducts in our homes until they naturally dissipate. Is that really what we want our families to be breathing? I don't think so. And our clothes dryers are also creating gas byproduct. I know that was the reason I used to change to a heat pump dryer. It was right outside my daughter's room. And so when that drum cracked, I was like, that's my signal to give up the gas dryer. I cannot live with myself if I continue having combustion byproducts outside my daughter's door. So star chefs are rallying to these things as well. They work like a microwave. They agitate the molecules in the pot and that transfers the heat to the food. So that means much less heat around the cooking area. It means a little kid who reaches up over the counter and touches the edge of that cooktop is not going to get burned. It means it cools off far quicker than a gas or electric cooking surface. Boils water in half the time. Far more pinpoint control to me than cooking over gas with the digital controls. So I really think this slide captures the inertia argument better than any others I've seen. The Sacramento utility did a survey before people had tried induction cooking, 80% negative impression of induction. Then they had them try it, 90% positive impression. I really think this is not a real thing. It's based on never having tried induction cooking and correlating electric induction to electric resistance, that old technology that maybe we grew up with, the glowing spirals. These are night and day different. And by the way, if IKEA is selling them and selling them for under $1,000, you know it's going to be mainstream. They don't take a gamble on anything in their stores. They see this coming too. You can find a slide-in induction range for, I want to say it's $1,000, $1,100 at IKEA. So go ahead. Tell me I'm wrong.
I can speak to that. At my previous home, we had the kitchen renovated, and I was kicking and screaming, didn't want electric, and the only reason I was forced into it was because we were on propane, and that would have been expensive. And I got induction, and it was like changed my world. I'm big on cooking. I mean, you can boil water in like a minute, right? And now that I've moved again and I have gas, and I hate it, and I wish I had induction again.
Thanks, Anthony.
I think you're wrong. I think Anthony's wrong as well. But I think anyone, I mean, I understand what you're saying, and I don't disagree with it. But it's just that people who like to live for eating and taste of good food and controlling the heat and really, there's a whole bunch of cook shows on television, a lot of them. And I don't see anyone using the electric. It's all gas because they're talking about cooking good food that tastes well. And it's not about how fast something is or how slow something is. It's about how you control the heat with the food and other things. So I don't know. I think maybe with time, as you indicated, everything will change. But I think a lot of people, they eat to eat, not to really enjoy their food. It's about being healthy and what you're eating. So I understand that logic as well. But those who like to enjoy their food, really, really enjoy their food, generally they go back to gas.
I'm with you, Drake.
I don't think they go back. I think it's like driving an electric vehicle.
They stay with gas.
They stay with gas. You're right.
They don't go back. Yeah.
It's like driving a Tesla. So I think we'll get there. But Drake's opinion is what we hear out there with my developers, my architects all the time. It's what we're up against. Right. Absolutely. So I'd like to invite Noma over, and we'll cook dinner at my house, and we'll let you try it.
Okay.
All right.
We get to pick what the food is, though.
You do.
Okay.
All right. So I really like this heat pump clothes dryer. I want to tell you about it too. Of course, you can get a standard electric dryer too. You're all electric that way too. But these have some nice features. You'll pay an extra $100 or $200 up front for it, but same concept. It's a closed loop heat pump. It's pulling the moisture out of that warm, moist air that's been blown through the drum and condensing it. And instead of blowing it out the building, it pumps it down the same drain that your washer drains through. How cool is that? So gone is that terrible sheet metal duct that gets crunched behind the dryer in every house I've ever lived in. And blows conditioned air out that you paid to heat and cool whenever you run the dryer. I just think the world of these things. They run at lower temperature. I find they're gentler on our clothes. They take 10, 20 minutes longer per cycle. That's a perception you hear out there that they take forever. Not true. And the energy use is comparable to the gas dryer, just all on the electric side. So I'm really happy with mine. This is what it looks like. I stacked it on top of my washer. They said I couldn't do that anyway either, but they make universal stacking kits. So these are great for retrofit. Mine's 110 volts, so I didn't need an electrician at all. Plugged it into the same outlet the washer's plugged into, been no problem. So those are the 4 end uses we need to convert to go all electric. Technologies are ready. In many cases, they're technologically compelling in terms of energy savings or quality of life. So I think you'll agree with me that the value proposition of all electric isn't just a tree hugger value proposition. Shall we go into Title 24 compliant? All right. I had a battle on a 17-unit building in LA with a mechanical engineer who was convinced I couldn't make heat pumps work in my Title 24 model. And he was right in the 2016 code, but now with the 2019 code, it's a completely different situation for modeling electric systems. Let me show you how. We have this new electric modeling pathway. This is the California Energy Commission recognizing that electric systems are a big part of the solution to our climate challenges. And yet Title 24 had these weird incentives, inadvertently built into them that would make, for instance, a heat pump tougher to comply than a gas furnace. And so what they've done is they've bifurcated the two. They said you can have a gas modeling pathway where you'll be compared. If you put a gas heater in your house, you'll have a gas heater in the standard house you're compared to. Or if you choose the electric pathway and you put a heat pump in your house, the standard house is going to have a heat pump too. Separate but equal pathways to compliance. So that has changed everything. It's given us a equally practical path to compliance for heat pumps, heat pump water heaters, as for gas, with a gas furnace and a gas tankless water heater. Of course, the appliances that I showed you, the dryer, the cooktop, aren't part of the regulated loads. They don't count for Title 24. So that has made everything easier. So now at least we're on a level playing field with gas. And we've got some compliance credits in the 2019 code we never had before. VCHP, variable capacity heat pumps, is the CEC's new term for mini splits, like I showed you earlier. Those heat pumps that aren't just on and off, but modulate their delivery of heating and cooling according to the load. There's a credit available for that. Also, if we put in NEA Tier 3 heat pump water heaters, they perform well in the software. So let me show you exactly how well. I modeled a typical 2-story house, and I modeled it, this is heating and cooling now. I modeled it with a typical 14-SEER 80 AFUE gas furnace split system. Then I modeled it with a central heat pump, that's the yellow bars. And you can see some climate zones did slightly better, some did slightly worse, but overall, the compliance was 0.6 EDR points better for a central heat pump than what we've always used. And when you go to the VCHP, that's the blue bars, 5 EDR points better on average, and the colder the better. Eureka, Truckee perform the best. So these VCHP credits are an absolute key to 2019 Title 24 compliance. It's one of the few things I can use to get a difficult accessory dwelling unit to comply. So I encourage you to look into those, if not for technological and comfort reasons, for Title 24 compliance reasons. On the water heating side, similar story. I modeled a gas tankless 0.81 UEF, and then I modeled a generic heat pump water heater with a UEF of 3, which is not a very high performing unit. You can see on average slightly worse than the gas tankless, 0.8 EDR points. When I turned around and I modeled a make and model specific NEA Tier 3 heat pump water heater, such as made by A.O. Smith, Bradford White, Rheem, GE, they all have them, I got a good bump, about half an EDR point better than the gas tankless. So hopefully these results show you in charts that what I said up front about the electric modeling pathway is true in practice. Questions on the Title 24 piece? Great. How about cost? We can't ignore cost. I'm here to tell you, these all-electric homes and multifamily buildings can be lower cost too. Because too often our cost analysis ignores the cost of the gas meter and the gas infrastructure to the lot. If you've already got gas to the house and you're doing a remodel, sure, you may not have this savings. But if you're working on tract housing where they haven't run the gas lines yet, or a multifamily building where, you know, if you're like me, I do projects in LA all day long where they're knocking down the old house and putting up a 3-story multifamily building. They don't have gas lines that they need to fuel a big building like that. There's a ton of money in infrastructure, and you need to include that in your analysis to really do the client justice. So eliminating that saves time and money, saves the occupants from having to deal with a second utility. Heat pump dryer, no vent. If you have no furnace, you've got no need for those vents through the facade. I think that was Drake's point earlier. Potentially no ductwork if you use ductless units. And I've also done a lot of analysis on operating costs. I always was told gas is a cheaper way to heat a house. And that may have been true when those adages started. But it's really hard to analyze, isn't it? Gone are the days where we can just put 12 cents a kilowatt hour and $1 a therm and figure out, because we got time of use rates, we got them interacting with solar panels, it's a complicated spreadsheet, let me tell you. But I've found agreement to the research studies which show lower operating costs for all electric systems in almost every case. This same study I referenced earlier looked at first costs of the systems, 4 different climate zones, single family and multifamily. In almost every case, the all electric new construction was cheaper than the mixed fuel.
Well, I wouldn't say that was 4 different climates. How about something like Chicago?
Yeah, we're talking just California, absolutely.
Okay.
If you do work elsewhere, I'm not talking about that. Yeah.
Well, what's the total kilowatt hours for all of these appliances? Is it something similar to like Passive House that uses like a benchmark of like, I think it's like 120 kilowatt hours for all appliances for heating, cooling, dryers, all that kind of stuff? Is that how you're sort of framing
what I'm assuming here is a lot of these concepts apply to retrofit too, but I'm really focused on new construction. But in 16 climate zones in California, it's hard for me to give you an EUI number. You know, it's so different. But we're not building these homes to passive house standards, no. I'm assuming sort of code minimum walls and attics and other systems, which is a pretty high performing home compared to what we built 10 or 20 years ago. But, you know, it's mainstream. It's what builders are building. So unfortunately, I can't quote to you a kilowatt hours per square foot, except to say, you know, Title 24 compliance is going to be the same or easier. First costs, as I'm covering here, the same or roughly a push. Operating costs should be a little bit lower. So even the economics, if you design your project right, can support the transition to all electric. This was another study. Here you see the site infrastructure for gas at the $6,000 savings to go all electric. Even if you put that aside and you look at $200 savings on the heat pump, $600 more for the electrical panel for the all electric, but $800 savings on the gas lines in the house, even ignoring the gas infrastructure, you can come out roughly a push on an all electric home. We didn't want to just leave it there, so we surveyed some SDE territory HVAC contractors, and we said, let's say your retrofit application, 2,000 square foot house, you're replacing a typical HVAC system, and your homeowner wants you to bid a like-for-like gas furnace split system and a heat pump. The like-for-like gas furnace split system came in a range $7,500 to $12,000. The central heat pump, $7,500 to $15,000, and 2/3 of those contractors gave an equal or lower bid for heat pumps. This is what I hear from contractors all day long. About the same for a heat pump. So just because they have technical superiority and we may not be familiar with them doesn't mean they have to cost more. Looks like I got about 20 minutes left. Are we okay to go to 7? Is that what you were planning on? Okay. How about utility costs? SCE put together a heat pump calculator that lets you put in climate zone, zip code, how old the house is, what the existing HVAC system is, what the new HVAC system is, and it'll tell you if it's going to cost you more or less on a typical home. And I tabulated those results in the graph shown to the right. Blue bar is a gas furnace split system. Orange bar is that ducted variable capacity heat pump. In every Southern California climate zone, utility costs considerably lower for that ducted heat pump. Might cost a little more up front, but that's going to pay off in several years. So don't let them tell you gas is always a cheaper way to heat a house. How about water heating? Different picture here. Heat pump water heaters are not necessarily going to be cheaper than gas tankless water heaters, but my analysis showed them roughly a push. These are PG&E climate zones. This was a PG&E analysis that we did. But you see, on average, $65 more a year to run a heat pump water heater than a gas tankless. That's roughly a push, I would say. And it ignores solar panels. It ignores programming your heat pump water heater to run only in low cost periods. So unlock those things, or take advantage of a rebate program, and your heat pump water heater is going to be clearly ahead. I wanted to cover electric rates with you real quick. These are the current time of use rates in SCE territory. Summer on the left, winter on the right. You see that 4 to 9 p.m. periods where they're really going to give you the incentive to save. Well, did you know that they have a special rate plan for when you go electric? It's called TOU Prime. And they're still going to focus you on that 4 to 9 p.m. period, charge you more. But look how low cost that electricity is for the other 19 hours a day, 17 cents in summer, 16 cents in winter, compared to 26, 27 cents. This is their way of saying, if you put in heat pumps or get an electric vehicle, we're going to give you the incentive to do it. So I would encourage you, if you work with clients who are thinking about heat pumps, get on this right now before it disappears. It really makes the economics sing. There are a few incentives in SCE territory right now. The California Advanced Homes Program will give you a $2,000 rebate for an all-electric home, $1,000 rebate for a multifamily unit. Do have to be slightly better than Title 24 to qualify, but I've found it quite practical to use. They also have incentives on heat pump water heaters to the distributor right now for retrofit only. Stay tuned because there's a lot in flux right now. Dave's going to jump in if I don't say this. There's a statewide incentive program coming. And so SCE has their programs just to fill the void until that statewide program comes online. So these are sort of all sunsetting. Some of them may go away before you get a chance to use them. But Charge Ready 2 provides incentives for EV charging, both existing and new multifamily buildings, especially disadvantaged community multifamily buildings. They'll pay for the whole thing. So check that out. And of course, we've got the federal tax credit for solar and storage, and SCHIP, which is the state program for battery storage. I wanted to mix in a few slides because one of the counterpoints we get to all electric homes is, yeah, but the electricity is made from gas and coal. So it's all, smokescreen. Not so, because remember, the state has set itself this 100% renewable electricity by 2045 goal. And they've done it well in advance so that they could signal the industry to start developing these technologies and investing in it. And this resolve model includes the intermittency, the uncertainty, and multiple weather years. And it shows us exactly how we're going to get there. From the current mix of electricity in 2020 to the 2045 compliant with all those laws stage, look at all the battery storage it's going to take. And look at the wind in light blue, the rooftop PV in pale yellow, the utility scale solar in bright yellow, and the natural gas shrinking. Still, there's going to be some gas on the system to help us get through those rainy days. But our scientists in California are already looking at what this looked like. Another study here took a look at, if we do nothing, this is our greenhouse gas emissions in 2050 on the left, and what's it going to take to get to the compliant pace? A mix of building efficiency, renewable grid, electrification of buildings, why we're here today, electrification of vehicles, and others. So this isn't pie in the sky stuff that our legislators just threw against the wall. We know what this looks like. I'm going to skip that one, but you've got it, and feel free to email me if you want to talk about it. Duct curve as well. Just so you know, net metering, it doesn't pay to overproduce solar. They're going to give you 3 cents a kilowatt hour for extra produced over the course of a year, right? Typically, our net metering plans settle up at the end of a year, so we're not paying them and they're paying us. But this is fantastic to the growth of solar, to be able to use the grid as our virtual battery. And these rate plans are evolving to better reflect things like the duct curve, things like the more and more solar we put on roofs, the more and more difficult it is for the utilities to manage the grid. So that's why they want us to build an efficient home and put a right-sized solar system on it. And we put a whole lot of extra, there's not going to be money in there for us. What about battery storage? This came up earlier. It's a great answer to this mismatch between when our homes produce and when we use electricity. Store the extra produced during the day, release it in the peak period, probably save a few $100s a year doing that. There's also a Title 24 compliance credit effective now for building a new home or a new multifamily building with batteries. So that can substitute for envelope measures or allow you to have a ton of west-facing glass. So you can make use of that. The cost effectiveness is likely to improve just like PVs did, right? As volume grows, price come down, and that's exactly what this compliance credit is in there for. And there's going to be a lot of exciting stuff between batteries and homes and electric vehicles and bidirectional flows. I can't wait to see what happens. But that's the concept. Charge the battery with the excess solar during the day and discharge it and lop the top off that peak in the evening. As we said before, our solar systems don't produce power in case of a blackout unless you have it hooked into a battery and you've specifically wired that battery so that it can island, so that it can operate in isolation from the grid. So make sure if you're working on a battery project, you design this in. An islanding inverter, typically driving a critical load panel that'll stay on in case of a blackout or a natural disaster. There's a new carbon metric coming in 2023, Title 24, that'll give us even more incentive to select low greenhouse gas emitting options, i.e. electric designs. So I wanted to paint a picture that this value proposition is compelling as it is now. I didn't want to paint the picture for you folks that we're only doing all electric because the government tells us to. But more regulation is coming. This is going to be, I think, a tide we can't fight. I have some case studies, but I think probably our last few minutes are better spent with questions.
Can you speak a little bit more on the battery island slide with the grid?
Yeah, so when the power grid goes down, all the inverters on our solar panels do too. They're designed to have a safety disconnect like that. And so if you just happily install your Tesla Powerwall next to your inverter without thinking about it, your battery is going to be useless in case of a blackout too. So what you need to do is wire it into so that it can operate with your solar system, receiving power throughout the day, even if the grid's down. That requires a certain type of inverter called an islanding inverter. And then hopefully you wire a critical load panel that operates straight off your battery. So that way, if the grid goes down, your battery can continue driving their fridge, critical lighting, phone chargers. You're not likely to be able to live your normal quality of life in case of a raging wildfire around your house. But you can keep the food from spoiling in the fridge. You can keep your phones charged.
Thank you. Yeah, that was great. Thanks.
Can you speak on pool heating?
Yeah, good question.
Yeah. Recently, I've had solar put on, but they denied me. They would have denied me if I had an electric pool heater.
Yeah, they make heat pump pool heaters. I don't have firsthand experience with them. If anyone does, please chime in. But I'm told they work just like the other heat pumps I showed you, and they're effective. Because if you think about it, heat pumps are great at just operating in the background at low load all the time. Well, that's what a pool heater does, right? Just gradually maintaining that temperature of the pool for year-round enjoyment in Southern California. I gotta think these heat pump pool heaters are able to do the job. And there's several manufacturers out there. And you can absolutely drive them off your solar panels now, right? And they're going to drive up your electric usage, but you can compensate that with added PV production.
My guess as to why they denied you is because obviously that electric pool heater is going to be a huge draw on your bus, right? So the physical copper inside your panel can only withstand so much. So typically your solar is, put at the bottom of that, physically at the bottom of your copper bus, and adding that energy that's produced by your solar plus your other loads can cause heating issues on your bus. So that's usually why. The other option you could have probably gone with is to upgrade the size of your bus to, I don't know, 400 amps or whatever the case may be, and still keep the same size main breaker as long as the loads are okay.
Yeah, and I wonder if what you were looking at was an electric resistance pool heater, not a heat pump pool heater. Because the heat pump would pull much lower amps. Thanks, Anthony. Again.
No, that's perfect. Some of the newer homes that I'm doing, or larger homes that I'm doing, are going 400 amp. So that should not be an issue, correct?
It shouldn't be, but it depends on what other loads they have. I mean, if they, have a 4 or 5 car garage with multiple, test or EV chargers. I don't know if they have like electric saunas, all types of stuff. I've seen some crazy stuff in custom homes. So it really depends. Even if it gets to the point where that's a problem, you can still upgrade to a 600 amp bus, but still keep a 400 amp main breaker.
Yeah, Michael probably has some of those homes with turntables for the cars.
Yeah, you're absolutely right. Or at least multiple lifts inside the garage.
Nick, that.
Go
ahead.
Dave, yeah.
No, I was going to say that just the discussion of multiple EVs and kind of load. Can you talk a little bit about coincident load and load management and some of the load management devices that can help with, kind of some of the end uses and how you kind of control and time those?
Yeah, and this is something we never had to worry about before, right? We just added up the kilowatt hours on our bill at the end of the month, and if we were a residential customer, it didn't matter when we used it. Now we've got time of use rates, so we've got a signal to think about when we use it. And if you add up all of you and your neighbors' usage, and you put yourself in the position of the transformer in your block, it does matter if you're all using power at the same time, and that's what the grid operator has to manage. And so we can keep our home's peak usage to a manageable level with load management devices. So these are emerging area. They might monitor, some of them come in the form of advanced load panels. So instead of a standard breaker panel, it's a solid state one that's tracking your usage on each circuit. And it might see you plug in your EV and realize it's got to send 30 amps over there and scale back your cooktop, the power that you had reserved for your cooktop or hose dryer or pool pump. And so you can program them to have must-have loads, nice-to-have loads, easy to reschedule those. And that's one of the emerging technologies that will enable this renewable transition as well. I should have mentioned on retrofits, there's also circuit sharing devices where you could have your EV charger and your pool pump on the same circuit. And it's set up so that only one can run at one time. So that frees up, it allows you to fit more into one panel. And those devices are good for difficult retrofits where you don't have the budget to upgrade the panel to. Melvin had a question. Are these appliances affecting current codes and fire code? Well, I've been looking at the upcoming 2022 Title 24 code, and in that code is a requirement that if you put in gas systems, they are pre-wired, they're electric ready. So there's, for instance, you put in a gas tankless water heater. This proposed code will require a 220 volt outlet and circuit be installed right next to it. So when that water heater fails, there's an electric retrofit option. And the same is proposed for cooktops, to have an electric 220 volt outlet, and clothes dryers. So absolutely, the codes are adjusting to support this transition as well. We're at time. It was hard to fit all that material into a small space and still allow you guys a chance to participate. So please continue the discussion with me if you'd like, or with each other. Here's my email address. And tune into the full 4 hours June 10th if you're interested in learning more.
All right, thank you very much, Nick. Lance,
Thank you.
Did you have anything you wanted to add, or we just end it? I think Lance is busy. All right, well, thanks everybody for attending.
Thank you.
Great group, really enjoyed it. Thank you.
Thank you so much.